All right, hello everyone. If you're watching this video, it's because you need help with this packet. This is the functions packet 2. Uh, Essentially, it's the basics of functions. So I'm going to go over some of the basics of functions. And one of the first things I'm going to ask is like, what is a function? So a function, if you think about it, like in terms of the English language, is something working, and also what is it doing? Like how is it working? That's what a function is. In math, it's a little bit different. It has to deal with like the amount of inputs and outputs, and this is essential for like a lot of computer programming. So right here, this is an image of some code. One of the easiest ways for me to explain to students what a function looks like, because a function isn't really something that's physical. Think of it like a vending machine. So it's a vending machine or a machine, an ATM. I think this is like the first explanation of like technology. And so with the function, you have to understand that you select and you put your money in and you expect something out. And if you don't get what you're expecting, then that's when you know a function isn't working, or you say it's just not a function. And this is true for like buying a parking permit, or going to the ATM and withdrawing money, or turning on your TV. There's so much technology out there, and you want them to work. With the function, there's inputs and then there's outputs. And so you put stuff into it. Sometimes it could be in the form of money and actually like putting in your PIN, or maybe it's just a connection. But inputs doesn't even have to be something like that. It could be something as simple as like you giving somebody like your own opinion, like you talking to someone and you saying like, "Hey, this is my input," and then you get to see what's the output, like what comes out. Everybody wants to contribute, and this is why I think functions are really important, because you have to start paying attention to your life, and you have to start to decide, is something working out or not working out. And you can probably remember something like when you were like a little kid, and something as simple as like, hey, like, is this candy machine my candy machine? Now as an adult, you see that you have a ton of different options, and there's a lot of different things that you might want or not want. And technically, like, your whole life is has so many different aspects, like, of things that you can do. um, so you have to ask yourself, is this working for you? Like, is this relationship working for you? Is the job that you have working for you? um, the path that you're on, is it working for you? Do you want to have kids? Like, there's so many things that you guys have to ask yourselves to decide if that's what's working for you. And when it comes to functions, you have to be able to, at least in math, be able to identify them. Um, like in real life, it's like if I asked you, can you identify a police officer? Can you identify uh, a military person, or something as funny as like a wizard, or an ambulance? So one of my first tasks for you guys is to like, can you identify functions and understand that there's so many different types of functions. Once you identify them, you have to check, does it work, does it not work, what's the input, what's going in, what's going out. And mathematics explains a lot of stuff in like your real life. So this is like the first opportunity for you guys to start to think like the next level up. So I'm gonna go ahead and pull up right now the packet. So give me a second. So here's the packet. We're gonna go over this packet. We're gonna start off with part one. What's a function? And I already told you a function. Think of it like a vending machine. It's really like a machine Um, but really, a function it's a relation where you have an input and you get exactly one output. That's the math definition of a function. And so there's a lot of different ways to look at a function. We can take a look at individual points. All of these are points. These are sets connecting to points, and we can also think of them as graphs. And so we're going to look at graphs in just a little bit. But the first aspect of a function is you noticing, okay, what are my inputs? What's going in? And the main thing that you have to understand is that a function is a relation that pairs each input with exactly one output. So for example, if I plug in 1, I get a 0 out. I plug in a 2, I get a 4 out. I plug in a 3, I get a 6. Plug in a 4, get a 10. Now, this is a function. This works. It's not broken. If I press one button, I get something different. There's nothing that repeats. When a function isn't working, it's like this example over here. So this is not a function. And this is pretty much like the only thing you really need to understand, like in terms of what's a function. See how this 3 goes to 2 different points? That does not work out. And sometimes I used to tell my students, like, think about a relationship. If you have a boyfriend or a girlfriend and he's going to you and then he's going to someone else, does that work for you? Now, obviously, that's up to you to answer that question, but this is a very simple way of understanding if the function, the machine, works or not. Think of it like you go to this machine, this vending machine, and you press the 3rd button and you get your item that you want, a 6, and then you go back to the machine. You're like, hey, I want some more of those chips or soda or whatever it is that you get, water. You press it again, but this time you get something different. That's when we know it doesn't work. So this is not okay. This is the part that makes it broken. And so we don't see any numbers that repeat. 1, 2, 3, 4. These are inputs. So if they're all different, then you're good. You don't have to worry about it. The problem is when you see one number going to 2 different spots, and that's where it's wrong. And I'm going to show you some more examples in just a bit, but just bear with me. All of these have exactly 1. If you see something like this is easy, okay? 1, 1, 1, 1, 2, 1. This is perfect. You don't have to worry about it. Now, what about this example? Again, these are the inputs. These are the outputs. A 6 goes to a 3, and then an 8 goes to a 3. Is that a function? That's something you have to ask yourself. Well, in terms of math, this 6 has one output, 3. This 8 has one output, 3. It's the same output, but that's okay. What's not okay is when one number has 2 different outputs. So technically, this is a function and this is a function. So these are good. So let's take a look at some examples. So determine whether each relation is a function. And so the first thing I like to do is take a look at all the inputs. And if they're all different, -4, -3, -2, then yes, this is a function. What about over here? There's a 1, a 2, and then a 1. Okay, 1 repeats. So that's like saying 1 goes to 3, but then 1 also goes to 6. And that's what's wrong. So this is not a function. It's a relation, okay? So there are some relationships where, one person goes to 2 different people, and some people are okay with that. But for our definition, this is not good. So this is not a function. So let's see, 0, 4, 7. They're all different. So as long as they're all different, then we're good. Now, you might say, Mr. Martinez, what if a number repeats 8 and 8? But see how they go to the same number? So that's okay. So it's okay if the number repeats as long as it goes to the same number. So this is a function. Don't worry about if there's essentially like the same output. You can have 2 different numbers go to the same number, and that's okay. I'm going to let you figure these out on your own. Sometimes you might see them in the form of a table. So here's a table. So again, here are inputs, 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 inputs. They're all different. So check, 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 check. So that's okay. So this is a function. -1, 1, 2, 2. Now see how 2 repeats and this 2 goes to a 6 and this 2 goes to a 9? It's the same 2. So that's not good. So this is not a function. These are all inputs different, 6, 7, 8, 9. They're all going to the same number. That's okay. Okay, that's okay. It's like think of it like this. You can get your bachelor's degree from college if you go to Cal State Channel Islands, if you go to UCSB, you go to Cal Lutheran, you go to UCLA, you can still get your bachelor's degree. That's okay. You can also think of it like, let's go back to this example. Like you might say, hey, Mr. Martinez, here's the vending machine. But this 6 goes to that 3. This 8 also goes to that 3. Think of it like buttons. Like sometimes you see in a vending machine the same button for like say a Sprite. And they do that because sometimes like one button is gonna run out of Sprite, but they know Sprite is super popular as soda. Not that I know because I don't drink soda, but you might need more buttons to get the same results. So that's okay. It's okay to have multiple buttons to get the same results, but it's not okay to have one button give you different results. Like if you want something to work, it doesn't work if it gives you different results. Only if you're getting the same result from one button, but you can have different experiences give you the same result. Okay. Let's see. Let's go back over here. Number 10. 7 gives you 9. 7 gives you 8. 7 gives you 7. 7 gives you 6. This is not good. So this is technically broken. Okay. Now this might be a little confusing because you might say, hey, Mr. Martinez, why is it okay that, you know, two different numbers can go to have the same results, but one thing gives you two different results? It just happens to be that these are the rules for mathematics, and this is what we use to understand whether something works or not. There are many different types of relations, but for math, this is what we use. It's basically one input, one output. But if one input gives you multiple outputs, then that's when it's not working for us, at least. So let's flip the page. When looking at a graph, there's a very simple test that helps us. Let me see if I have a vertical line. I don't, but I do have this chopstick right here. So there's a test called the vertical line test. And this is a method used to determine whether a graph is a function or not. And basically what people do is they get a line, a vertical line. So pretend this pen is a vertical line. And if you go through the graph and it only touches exactly at one point, then this is a function. Okay? And you can think of it as like you draw like a bunch of straight lines, vertical straight lines. And you notice it just touches once, just touches once, just touches once, just touches once, just touches once. This is a function. If it touched in two different spots, for example, if I run my vertical line test across here, and even if I just draw a line down here, you're going to see it's going to touch in a bunch of different spots. 1, 2, 3, 4, 5. That's definitely not a function. Okay? It should only touch once. So that's a very simple trick for you to determine whether something's a function or not. So we have 9 different examples here for you to decide whether it's a function or not. So I recommend you pause the video and see if you can figure it out on your own. But this is very simple. But if not, just go ahead and pause it. Run it through. Yes. This one, it's a circle. So if I draw a vertical line, there's going to be parts where it touches twice. So that's a no. This one's kind of tough to decide whether it's a function or not. But I actually don't think there's any straight lines that go up. They're all diagonal. So I would say this is a function. This one too. Just once. This one has many places where, like, if you draw a vertical line, it crosses several times, so that's no. Number 6 is kind of tough because you see how there's a circle right here, but this is an empty circle, a hollow circle. This is a completed circle, so if I draw a vertical line right here, the point's there. It's not actually there, so this is a vertical. This does pass the vertical line test, so it is a function. Now later on we're going to learn about discrete and continuous functions. These are discrete, how they just have points. But see right here, boom, failed. Over here, let's see. This one's not straight, but I think this one is. So if I do that, we see 2 points, so that's a no. This one looks good. So we had 4 no's and 5 yeses. Okay. Again, when it comes to functions, I want you to think about like your life. Is something working out? Is the relationship you're in working out? If it's not, you gotta let it go. Is your job working out? If it's no, then you gotta let it go, find a new job. And this is good practice, because remember, math is supposed to explain your entire reality, your whole world. It's not that hard to tell whether in math if something's a function. And it's the same thing with your life. It's not that hard to decide whether something's working out or not, but you have to make the tough choice of moving on. Okay, now some more basics. There's now part 2, domain and range. Now every function, for it to be a function, it's a machine, you have to feed it, you have to give it stuff, and then the function works and spits stuff out. The stuff that goes into a function, we call this the domain. These are the inputs. Okay, so there's the machine, works, and then it spits stuff out. That's called range. These are the outputs. Okay, so the domain is a set of all possible input values. Domain is what goes in. Range is what goes out. Okay, and it's not that hard to tell what they are. The inputs are always going to be the first number. Okay, and then this is how we write the inputs. So it's the set of -4, -3, -2. We write these brackets. There's a lot of different ways of expressing domain and range, but this is one of them. And then range is the second numbers, the ones that go out. So again, I'm going to do my little brackets. 4, 5, 6. Okay. Now, even if it's not a function, that's okay, because I can tell off the bat, like, hey, this is not a function. 1 goes to 3, 1 goes to 6. So this is not a function. Okay. But we're just working on domain and range. So I want to know what the inputs are. So again, domain is all the numbers that go in. So 1 and 2. Range is all the numbers that go out. So 3, 4, and 6. Okay, but keep in mind, this was not a function. Domain 0, 4, 7. Range is 5, 10, 7. And we could have put these numbers in order if we wanted to. I don't want to steal all the fun, so I'm going to let you guys pick domain and range for these. Again, the domain, just remember, it's the first numbers. Range are the second numbers of each point. So this is a point, that's a point, that's a point, but a point has 2 different parts. It has the part that goes in and the part that goes out. So hopefully you guys can figure these out on your own. Let's see the domain over here for a table. Domain, again, is all the inputs. So 0, 1, 2, and 3. Okay, that's a very weird 3. This is a Korean 3, okay? Just kidding. Range 2, 4, 6, 8. So again, so far, all of these basics is just simple things that you guys have to consider. Just patterns. The domain, 1, 2, 3. Almost messed up my 3 again. I think it's because I'm doing these brackets. Range, 7, 8, 9. I'm gonna let you guys do these two, so I don't steal all your guys' fun. But that's domain and that's range. Range is what goes out. Domain's what goes in. Domain are also all the x's. And the range is all the y values, all the y's. Okay. Let's flip the page. And all right, so we're still finding domain and we're still finding range. In a graph, it's in the form of points. So we have this point, that point, this point, this point, this point. And remember, the first number is the x value. So this x value is 1, and then the y value is 2. So you go 1 over up 2. This one is 2, 3. This one is 3, 5. 4, 5. And then 5, 6. So the domain is all the numbers, the first number. So we have 1, 2, 3, 4, 5. And the range is 2, 3, 5, 6. Okay. Now, if you're looking at a graph and the graph isn't just points and it's a line, we can rewrite domain a little bit differently. Remember, domain is all the x's and the range is all the y's. So the domain goes as low as 1 and as high as 6. So I'm going to write a 1 and a 6 here. But notice how this is a closed circle, so that means it includes a 6. This is an open circle, so it means it doesn't include a 1. So I'm going to put an inequality sign that does not have the little line on the bottom, so it means it doesn't include 1. And in this case, I'm going to do this, and it's going to say, oh, it includes 6. Okay? So there's my domain. My range is all my y values. So notice, what's the lowest value? It's 1. What's the highest value? 5. So it's between 1 and 5. So 1 and 5. It includes the endpoints. So I make sure I put the little lines on the bottom. You might say, but Mr. Martinez, isn't there like an open circle? But yeah, but there's a point here that includes that open circle. So it's continuous. Number 3, this one's interesting. It's a straight line, meaning it's going to go on forever in both directions. So it's for domain, it's how much you go to the left and right. So this is going to go forever to the left and forever to the right. So this is negative infinity to positive infinity. And the range is going to be the same because it's going to keep going down, 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 and it's going to keep going up, 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 up. So negative infinity to positive infinity. All right. Pretty simple. I hope this is easy for you guys. In class, I'm basically going to give you guys time to see if you guys can figure these out on your own. So you might want to pause the video right now and see if you can do it on your own. If not, just follow along. But the domain is all the x's. This is the x-axis. So you're looking at these numbers. So 2, 4, 6, 8, 10, 12. So this is 2, 4, 6, 8, 10, 12. Range is all the y's. So 10, 12, 14, 16, 18, 20. Okay. A little messy, but hopefully you guys still understand it. Now notice this has open circles. So this means it's not going to include the endpoints. The domain is all the x values. So everything on this line. So it goes from 2 to 12. Domain is from 12 to 16. This is closed, so this will include the endpoints. So that means that we're going to be putting little lines on the bottom of these inequality symbols. And domain, again, is the x value, so it's from 2 to 12. So we put a little line on the bottom because this is closed. It includes it. Range is from 10 to 19. Let's see. So we have these that are just points. So I'm going to let you guys figure this one out. But just remember, domain is all the points that touch the x-axis. Okay. And then range is all of these. Okay. The only tricky one I would say is this one. So I'm not going to do this one so that you guys can work on it, but this one's a little tough. So domain, all your x values, it's from 2 to 12, but it includes 12, so we put a little line on the bottom right there. The range is all the y values, but if you pay attention, it only touches at 16, so this is literally just 16. That's its full range. It doesn't matter what you, basically, as long as you plug something in between 2 and 12, you're going to get a result. That's what it means. Anything less, it's not going to work. Anything more is not going to work. But whatever you plug in from there, you're going to get a 16. Okay? Okay, flip the page. Now we're going to move on to different types of functions. Okay? So you have to understand that there's so many things in life that you pay attention to that is a function or not a function. So you can ask like, hey, is your school working for you? Is your car working for you? Is your family working for you? Is your government working for you? And then you have to decide whether it's working or not working. So there's so many different types of functions. Obviously, with our eyes, it's a little bit more complicated. It's not just simple lines, but the first type of function is a line. It's called a linear function. So let's go ahead and write this down. A linear equation is an equation that can be represented in this format. So y equals mx plus b. I'm sure you guys have heard of this like many times. This is basically this example where it's just a straight line. So I should have probably brought a ruler. So this is probably the most basic form of functions. It's a consistent pattern. Very simple to identify it. But but there's a ton of different types of functions. So if you see, there's absolute value, exponential, quadratic, cubic, root, sine, cosine, tangent, and then within all of these, they can take all kinds of shapes and forms. These equations are in technically between 1 and 2 dimensions. It could be up to 3 dimensions, but basically it's on a 2-dimensional surface. It's flat surface, okay? You aren't going to be paying attention to functions that are 1 or 2 dimensional. Your functions are 3D, like basically stuff that you can see. And then that's what you're going to be deciding whether stuff works out or not. And some of these things are actually in a higher dimension depending on your definition of dimensions. But let's continue with the different types. Absolute value usually looks like a V. Basically, it has a corner, like it just bounces, like pew, you know. Exponential, there, and again, there's different types of absolute value. We could have probably made like a, just like in this one, we can have another linear that goes down, and we can have an absolute value that goes up and then goes down too. Okay, so there's different types of absolute value, and there's different types of linear functions. There's different types of exponential functions. There's some exponential functions that start low, 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 and then all of a sudden they shoot up. And then there's some that start to get lower, 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 and then eventually they go down. So there's different types of exponential functions, but an exponential function has a sharp, like all of a sudden it just like takes off or goes down sharp or goes up sharp. Quadratic formulas, this is kind of like, think about like shooting something out of a cannon. Like stuff goes up and then it goes back down. You know, gravity takes fold. And you can have stuff going up and down, or you can have stuff going down and then up. Okay? This can also be able to like explain curves like in the solar system when like comets get closer and closer to like say the Earth. Okay, they just and then they go around. Quadratics have an x squared. Cubics have an x to the third power. Linear is mx plus b. Absolute value is the same thing as mx plus b, but it has absolute bars. And then exponential is essentially like a number to like a power. So that the x is on top versus the x being on the bottom. See how this is on the bottom? See how that's on the bottom? A cubic goes up, goes down, and then goes back up. And it can do the same, it can do the opposite. It can go up, down, and then back down. Okay, so these are cubics. Root function is kind of weird. It just kind of has like it kind of dies off. It can go up and then down and die off, or it can start down and then go up. And it can also like flip. But roots usually have like a dying point. And this is what a root function looks like. It's a square root. Cosine. Sine, cosine, tangent. These are the ones that I like to think that are like vibrations, and they start to like become real, because I think you already know by now, like from what you guys learned in science, that everything in this universe has a vibration. And like with cymatics, you guys have learned that sound can take shape, and everything in our world starts off as sound. I think it starts off like first as a thought, then sound, and then it materializes. So I like to think that these are the ones that create like all your guys' reality. A sine function is basically like a wave. A cosine is a wave just like this, but instead of starting at the bottom, it might start at the top or the bottom. Very similar to a sine. A sine wave. And then a tangent, I see these more like in vital machines, like when you go to like a hospital. But they do stuff like this. These have asymptotes. And they have like a very unique pattern. And nonetheless, all of these are patterns. But what I'm suggesting is that all of these combined make your guys' reality, and then you have to be able to identify them and label them and say, hey, what is this? What is this? So sine function, it's a root function, it's a quadratic. Is this working? Yes or no? Okay? So now within all the different types of functions, there are different types of domain, discrete and continuous. And the best way for me to describe it is like, I like to think about a farm, because I'm hoping I want to get a farm one of these days. I don't have a farm yet, but we do have cats, birds, dogs in the house now. Chickens lay eggs. Now they lay one egg at a time. So you can have one, you can have two, you can have three, you can have four, but you can't have 1.5 eggs. I've never seen a chicken lay half an egg. It would have to be like cut right down the middle. Basically what I'm saying is discrete is just whole numbers. So a discrete domain is a set of input values that consist of only whole numbers, while a continuous function has domain that are just constantly going. So think of like when you milk a cow, it's slowly like the bucket of milk slowly starts to like increase. You can have half a gallon, you can have a quarter gallon, you can have a full gallon, you can have 2 gallons. It gives you the whole spectrum. While discrete is just like one at a time. So when we look at discrete functions, they're very easy to identify. They're in the form of points. So this is discrete. If it's a straight line or any type of line, we would call this continuous. So this one would also be considered continuous. This one is a little challenging. See if you guys can think about this one. So, but let's fill out the domain first while we're at it, because these are also asking for the domain. So remember, domain are all the x values. So 2, 3, 4, 5, 6. Okay, that's where all the points are at. Okay, at 2, at 3, at 4, at 5, at 6. So domain is 2, 3, 4, 5, 6. Range are 4, 5, 6, 7. 4, 5, 6, and 7. So this is a little refresher with domain and range. See if you can figure this one out. Domain is between 2 and 6. And the range is between 4 and 7. And remember, we use Y for range, and for domain we use X. Now I know we've done this example before, and it's a straight line, and this happens to be true with a lot of functions. It's gonna go forever negative infinity and positive infinity. So another way of writing this is all real numbers. So you can do an R with 2 straight lines, and we call this the reals. It basically means all numbers. Like, it doesn't, the domain is all the numbers and the range is all the numbers. It's going to get you everything. Over here, let's see if we can figure this out. This is a horizontal line. The domain is the reals. Why? Because it goes forever to infinity and forever to positive infinity. And our range is only 5. So the question is this discrete or continuous? You only have 5 and that's it. It doesn't go up to 6, it doesn't go down to 4, and it just stays at 5. So I'm actually going to call this just discrete. It's just 5. It's just one. It's just or just 5 eggs. Think of it as eggs. It's just 5 eggs and it stays as 5. The growth of a tree, all right? It keeps growing and growing and growing. So this is continuous. It's not like all of a sudden it goes boop and it skips. Like, no, you can watch it on a camera and see that it slowly grows. Number of marbles in a bag. You take marbles out and put them in. There's no such thing as like, I mean, obviously there is such a thing as half a marble, but you're only going to get full marbles. So this is discrete. Okay. And if you guys have any questions, just let me know. Just you can ask me for help and I can help you guys out. But we're almost done. So we got the last part, part 4, notation. Maybe, I don't know if it's the most important thing, but I think it's pretty important. Because if you took the previous class before this one, you got essentially an algebra class, you learned a lot about equations. And so you should have a background of equations when you're taking this class. And even if you're not, don't worry about it. Like, I'm here to help you out. But you have to be able to identify when something's a function. And there's a very simple way of identifying when something's a function. Essentially, it's an equation, but it just has a different format. So let me explain. So function notation versus an equation. So this is 2x plus 9. This is also 2x plus 9. Well, what's the difference? The only difference is this has f of x. This is called f of x. F, and then the parentheses are of x. This just says y. Y equals. So anytime you see y equals, this is called an equation. Technically, this is also an equation, but now this is a special equation. This is a function. So anytime you see the parentheses and the variable inside the parentheses, the same variable over here, that's how you know it's a function. So let's go look at the definition. An equation is a statement with two things that are equal. But a function is a relation with a set of input and output values that follow a particular set of rules. So now it's like saying an equation doesn't have any rules, but a function is very specific and it has rules. So you have to pay attention to the rules, even though it looks exactly the same. This one over here, this is a function too. Even though it's no longer an f and this is a g, this is still a function. The function is called g of x. And there's a lot of different ways of writing functions. Sometimes this is not going to be an x. It might be a different variable. So that's something for you to pay attention to. But notice how this is very similar to an equation, except this one starts off with y equals, and this one actually has like a little bit more stuff. So anytime you see basically two letters in a parentheses, that's a function. So this is function notation. And the reason we have function notation is because it makes it easy for us to say what is being plugged in. So this is f of x, and this f of x is 2x plus 9. But if I say what's f of 3, notice I now replace 3 with x, then that means that you're going to replace 3 with x. So f of 3 is equal to 2 times 3 plus 9. 2 times 3 is 6, plus 9 is 15. So we say f of 3 equals 15. And that's the advantage of a function over an equation, meaning that we can tell it, hey, plug this in, tell me what's coming out. And again, sometimes the notation might not have an F, it might not have a G. Sometimes it's a whole word, sometimes it's a bunch of symbols, but you have to notice like, hey, there's something in front of it, that's the name, then there's a parentheses, and then there's a variable, whether it's an x or a t or whatever, because in this next example, you're going to see that there's a t. So interpret the following function. Let f of t, okay, so that's f of t, be the outside temperature of Anchorage, Alaska. So Alaska's super cold. And then it's starting at midnight, starting at midnight on December 5th. So the question is, what is f of 0? F of 0 is when it starts. What time did it start? Midnight. So this is the temperature at midnight. Okay. Now, we didn't specify what T was, but I think T is time in hours. Okay. So I probably should have done a better job of being more specific. So if I say F of 12, that's the temperature of Anchorage, Alaska, 12 hours after the starting point. So midnight, what's 12 hours after midnight? This is at noon. So this is the temperature at noon. 12 hours later. Over here, it's telling us what the temperature is at midnight. So it says, hey, the temperature at midnight is negative 10 degrees. Okay, so the actual temp equals negative 10 degrees. What about this one over here? F of 9, so this is the temperature at 9 a.m., is less than the temperature at, what's 18 hours after? So that's 18 minus 12, 6. This is at 6 p.m. So it's saying that it's colder at 9 a.m. than it is at 6 p.m. So see if you can understand what this means. Again, F of 0, this is talking about temperature. So it says, let this be the temperature of Anchorage, Alaska on this day. And we're going by hours. So what's the temperature at midnight? It's negative 10. What's the temperature at after 12 hours? Well, I don't know because it didn't give me an equals. All right. But that's what this means. It's like I'm asking for the temperature at noon. And then this over here saying that this is an inequality symbol saying that this is less than that. So this is more. So it's hotter, and then that's colder. So it's colder at 9 a.m. than at 6 p.m. Okay? Part 2, evaluating the function. So again, what's cool about a function is I can say, okay, if I want to know what is this when x is 5, 0, and negative 5, I just do f of 5 equals, and then I replace x with 5. So this is 2 times 5 plus 7. So 2 times 5 is 10 plus 7 equals 17. So f of 5 equals 17. And then I can do the same thing for the other one. So f of 0, f of negative 5. What does this equal to? Well, I now have to replace 0. 0 times 2 is 0 plus 7 is 7. So this is just 7. Negative 5 needs a little bit more work, so I'm going to plug it in. So 2 times negative 5, this is negative 10 plus 7 gives us negative 3. So f of negative 5 equals negative 3. Keep in mind with math, this is something, we're working with something. I don't know what it is. Real math should have something like this example over here where it tells you like, hey, it's a temperature. I don't know what this is about, but these are the answers, okay? It can talk about so many different things. So I'm going to want you guys to find g of x when x is negative 4, when g is 0, and when g is 8, okay? So all you do is replace your x with whatever number was replaced in the parentheses. So this is negative 1 times negative 4 plus 3. Negative 1 times 0 plus 3. Negative 1 times 8 plus 3. Okay? Now you guys can do this all in your head. A negative times a negative is a positive. So 4 plus 3 is 7. Anything times 0 is 0. So that's just 0 plus 3 is 3. And look, this looks like this is going down. So 7, 3. So this is something that's going down. Negative 1 times 8 is negative 8. Plus 3 is negative 5. Okay, so definitely going down. Let's take a look at some more problems. We're now going to evaluate graphs. Okay, when we're going to evaluate this graph when x is equal to negative 3. So look, see, f of negative 3, but this is your x-axis. So where is negative 3? 1, 2, 3. So that's negative 3. This is 0. 1, 2, 3. That's 3. So the result is the y value. So remember, these are your inputs. We want to know the outputs. So the outputs are the y's. So if this function is negative 3, where is it? Where is that? It's right here. So what's my y value that corresponds to that? 1, 2, 3, 4, 5, 6. Let's double check. 1, 2, 3, 4, 5, 6. So f of negative 3 is 6. F of 0 is right here. So that's going to be 5. And f of negative 3, if this is 6, this is 5, then that's 4. Okay? You might want to pause the video and see if you can figure this one out. Okay? But we're also looking for negative 3. So 1, 2, 3. So where is that at? 1, 2, 3, 4, 5. What about when it's 0? So 0 looks like it's at 6. And then at 3, 1, 2, 3. Let's go up. It's right here. This looks like it's also at 6. 1, 2, 3, 4, 5, 6. Okay. Now what's cool about functions is not only can you give inputs and find the outputs, you can also be given the outputs and find out what's the inputs. So basically going in reverse. So find the value of x. So when f of x is 10. So this is f of x, 2x plus 4. So I'm going to write this out equal to 10. So 10 equals 2x plus 4. And now we just got to work our way back like how we did in algebra class. So minus 4 to both sides. 6 equals 2x. We now divide both sides by 2 to get rid of that 2. These cancel, and I'm left with x equals, what's 6 divided by 2? 3. So what does this mean? It means if I plug in a 3 to this function, I'm going to get a 10 out. Okay? It looks like this on a graph. So x is 1, 2, 3. And then the 10 is at all the way at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be a dot somewhere over there. And this is our x, and that's our y. All right, what about this one? Find the value of x when g of x is equal to 15. So if this is equal to 15, what's the x value? So 4x minus 9, I'm going to put the equal sign on this side this time. Plus 9 to both sides. These 9's cancel. I'm left with 15 plus 9 is 24. 4x. Divide both sides by 4. X equals 6. So that means if I plug in a 6, I'm going to get a 15. Okay? Now, we can also do that with the graphs. And I try to make it easy for you guys. I even put the numbers over here. So find the value of x when f of x is equal to 7. So if this is our y value, what's our x value? 1, 2, 3. So x equals 3. Let's find the value of x when g of x is equal to 5. So here's 5. 1, 2, 3, 4, 5. So go like that. Bring it back down. 1, 2, 3, 4, 5, 6. Okay? Now, I recommend that you guys do your homework. You guys have 4 Delta math assignments this week. And it's essentially everything that we just did in this packet. Hopefully it makes sense. I try not to rush through this lesson, but yeah, my videos are a condensed version of the lessons that we have in class, so it's not exactly perfect. So if you guys have any questions, just ask me for help. But remember, with anything in your world, you have to ask yourself, is this functioning? Is it working? Is it working for you? And in here, this is how we learn how, if numbers work, but you have to translate this to your reality and decide whether everything in your life is working out. Again, it could be, I keep saying the same examples because I think these are the most important. Like, is your relationship working out? Are your friendships working out? Is your job working out for you? If it's not, then you have to do something, but you have to make those choices. So I hope I can make you a better person, via math. But again, it's up to you. Okay? So anyways, I hope you guys enjoyed this video. Give it a like, write a comment. But I'll see you guys in class.